Hey, today we are going to talk about a problem called minimum cost to connect all these points. We have a graph where we have a points. We have to connect all these points in such a way, if we sum up these distances, it should be minimum globally for this particular problem. We'll talk about how to calculate the distance, So the way to calculate distance, we have to move towards x-axis, the units are 2 here, and move towards y-axis, the unit is 2 here. To connect these 2 points, the cost is 4. That's called Manhattan distance. Okay. The way to calculate distance, we have to use simple formula like go towards x-axis and move towards y-axis, sum it up the distance, that is going to be the Manhattan distance. Okay, this problem we can solve it with two different approaches. Not two different thought process we have to combine and solve it. One is to connect any, in a graph algorithm, if you want to connect any two, what is the best algorithm to use, the data structure to use, which is find and union. Find and union is used to kind of construct a graph. If you have a node and if you want to kind of construct a graph, then find and union is one of the best, right? If you wanted to avoid the duplicate connections. Of course, like you can keep connecting as long as there is if there is no issues with duplicate connection. But in this particular case, if you want to, if you don't want to have any duplicate connection, but you want to do it efficiently, then find and union data structure is the best one to use. The other part is the core problem is when we connect, if you sum it up the cost, it should be minimum. That's the core problem, right? How do we do that? The way to do is take this point, which is this, and try to find the distance between this point to all other points, right? We'll have to try to find distance between this point to all other points and put it in an array. Okay, so from this point to this point, the distance is 4. From this point to this point, the distance is 13. From this point to this point, the distance is 7. From this point to this point, the distance is 7. Likewise, okay, likewise, we have done it for this point. From this point to all other point we have done. Same way, we have to take this point and calculate for all other point. Same way, we have to take this point and calculate distance for all other point and keep adding in this array. Once we constructed this array, like I, for a simplicity purpose, is only kept 4, but ideally it will have the distance 4 and the coordinate of this 0, 0 and the coordinate of the other one, okay, which is 2, 2. So these are the information we will be keeping it is in this particular cell or item, whatever we call, right? These are the information we have to keep because we have to sort using this number distance. Like we have to start using this number, and once we start, like we take these 2 points and try to find using find and union algorithm, okay, check whether these 2 points already connected or not. If it is connected, we don't do anything, we go and pick it up the next element in the array, sorted array. If it is not connected, we call in a union method to connect these 2 points. Okay, that's how we keep repeating it till we iterate all element. Right, once we iterated, and finally we will have a graph which is connected without any duplicate connection. That's where like find and union is best thing, right? What finally is going to have, finally this for this particular case, the way it's going to look like is this. Okay, so the distance between these two is 4, the distance between these two is 9, the distance between these two is actually 1, 2, 3, and the distance between those two is actually 4. Is that right? This is 4. Yes, this is 4. Yes, this is 2. This is 2, 4, and from here it's 2, 1, and all the way up, which is 8. 1 plus 8 is 9. All right. 9 plus 4 plus 3 plus 4, which is 20. Right? This is 20. This is the answer, right? Right. That's how we have to solve this problem. Thanks for watching.